Hey everyone, hope I'm audible now. Thank you all so much for joining this morning on a Sunday morning, in fact. So, this happens to be our very first meetup from Cloud Native Bhubaneswar. And to give a very brief overview of who we are basically, so we are a dedicated community backed by Cloud Native Computing Foundation, which oversees on the open source tools and technologies, Kubernetes being one of the very famous ones. And so the entire uh, goals and motivations of having this sort of tech communities and events is basically to uh, engage community folks among the open source technologies and basically give opportunities to the new upcoming speakers and pretty much expanding the open source community. So we have a great agenda of what the today for today is, and hence I'll be moving forward as in such. Yeah, so let's get started already as we are already on time. So for before the organizers for the Cloud Native Bhubaneswar, me Syed Imran. I'm currently working as DevOps engineer at Combin.ai, and I'm a Qstronaut. For the fellows who don't know about Qstronaut, so a person who has completed all the five certifications of Kubernetes is basically entitled to become a Qstronaut. And I believe, as far in the world, India leads the number for having the highest number of Qstronauts around the world. And it's indeed a proud moment for Indians to take over this place and being one of them. And I believe second or third from Odisha, in fact. So it's a great privilege indeed. And second here, my co-host is Anshuman Mishra, who is currently a research associate at IIC Bangalore. And uh, we have Sangram Rath as the one of the key organizers of Cloud Native Bhubaneswar. He's a cloud architect and technology advisor, and we do have them here with us. So yeah, that's pretty much the as of the organizers of Cloud Native Bhubaneswar we are, and we do look forward for more collaborations for people that are looking forward to take initiatives to build and grow together with Cloud Native Bhubaneswar. In case if you are willing to become maybe organize along with us or maybe volunteer for uh, taking some responsibilities, we do welcome new people. In fact, anyone who is willing to take forward uh, the community with us. So yes, moving forward for the speakers for the meetup, we have a very great speaker lineup. And we have Fazlur Rahman Khan from the Linux Foundation here itself, who is as working as technical trainer at Linux Foundation, and is also a Cubestronaut. So a very great thing to have two Cubestronauts in this meetup itself. And next we would have Rudra Madhav Mishra, who is working as cloud engineer at Amazon. And the third we have V. Roshan Kumar Patro, who is working as DevOps and SRE engineer at Misho. And last, me myself would be the speaker, and I would give up again. Of course, I'll be speaking up because I'm also an active speaker in a lot of community events, and I feel honored to be the host for the CNCA Bhubaneswar and the speaker as well. So, yep, moving forward with the session. So this would be the agenda of the meetup. Fazlur Rahman Khan would be speaking on where do I start the cloud native career training, and Rudra will be talking about from on Istio from containers to control plane, how Kubernetes and Istio work together. Roshan would be speaking about Cilium on breaking cluster boundaries and pod-to-pod networking, and I'll be speaking about the very I would say an unsung hero about Kubernetes YAML's flow, that is Crow, that's eventually growing but yet to be in the limelight. Okay, so let's not wait. We just get started with the very first talk. So I would be feels honored to kind of introduce Rahman. So Fazlur Rahman is India's very first technical trainer at the Linux Foundation and a seasoned course maintainer, author, moderator, and astronaut. He is widely recognized for his deep expertise in Kubernetes and the cloud native ecosystem, and for his impactful role in enabling professionalism to build strong, practical foundations in modern infrastructure and platform engineering. He has played a key role in educating and mentoring professionals globally, helping shape strong foundations in modern infrastructure and platform engineering. Rahman, it's to you.
Thank you. Thank you, sir, for kind information. Introduction. Let me quickly share my screen. Quickly confirming if you can see my screen, okay?
Yeah, we do see your screen.
Awesome. Thank you so much for such a kind introduction, Saeed. Without further ado, let me get started. In this 15-20 minutes, what we're going to interact right now, I'll talk to you about how you can get started with your cloud native training needs. And I will also talk to you about how do you get certified, why should you get certified, and how do you as an engineer improve yourself by contributing to open source. That's what my agenda of this talk is going to be, and make use of the Q&A box. While I'm presenting, I might not be able to look at it. To Syed, I would request you to interrupt me in between the talk if there are questions which you think I should answer. I would request you to keep an eye on the Q&A box and interrupt me, because when I'm presenting I would not be able to see that Q&A box.
Yeah, starting.
Awesome. Thank you. All right. I want to start it off with something which I saw recently on the internet. Just wanted to bring that out. Recently, we've seen in the last 2 months, we had quite a lot of outages, right? Because one day, the half of the internet was down because the AWS clusters were down. And then we kind of recovered from that. And we also had a Cloudflare incident where another half of the websites were not working in the world. And I happened to see this somewhere on the internet. I thought I should share this with you. If you look at the foundation or the right down below of this particular stack, what we see here, it talks about Linux Foundation. Trust me, I didn't make this up because I work for Linux Foundation. I saw this on the internet meme page. The reason I put this out there is to just to let you know the impact of what Linux has. 90% of our public cloud right now in the world runs on Linux. And if so, I can't interact with you, but then the top 500 supercomputers in the world, you know which operating system they run on? Obviously, they run on Linux. All 500 of them, 100% supercomputers run on the Linux. And if I give another example of the Mars rover, the Curiosity and Perseverance, which are running on the Mars right now, they are also running the Linux-based operating system. NASA uses them for their robotic systems. Right? Of course, the list is long. I'm going to cut short. The reason I brought it out is I found it nice. I just want to talk a little bit about the Linux Foundation, Linux, and the cloud native stuff. Now, this is me. I said introduce me. I'm going to skip through this. There's a few courses what I've authored and maintained for the Linux Foundation, the official courses around the Kubernetes and other cloud native stuff. So what are we going to talk today? I'm going to introduce you a little bit to what Linux Foundation is all about. What is the Linux Foundation education? And then what is this Cloud Native Computing Foundation, CNCF? Now we are looking at the CNCF Bhubaneswar as a chapter, but we'll just take an introduction. I know most of you, all of you kind of know what it is, but I thought I should bring it out a little bit so that it'll help in our understanding. And then we will see what you should do to get started in the cloud native as a young engineer, or as a fresher if you're looking at it, or if you're trying to transition from a traditional workload towards the cloud native app development story. This, and also I'm going to talk to you about a little bit of how to contribute to open source, either as a developer, and there are many non-developer infrastructure folks, and how you can contribute to open source, increase your presence, increase your portfolio, and and then help the community, and then also help yourself by doing so. This is the overall agenda going to be. I will try to keep it very crisp, not put you to sleep. And if you have questions, please do type in. A Linux Foundation, right, is a non-profit organization. This was established around 2000-ish to support and promote the growth of Linux as an operating system, the collaborative open source development, right? It's Linux is the most popular open source project on this particular planet. Now, this Linux Foundation was primarily built to support the work of Linus Torvalds, the creator of Linux, and also the lead maintainer Greg Hoffman. So the foundation was created so that somebody could fund his work and maintain that kernel development process, right? And foster your collaboration. Linux Foundation initially was built for that, but quickly over the time, Linux Foundation became a mother body umbrella of hosting multiple open source projects in the world. It's a vendor neutral ground where it helps in collaborating, hosting projects, communities, conferences. It kind of provides a neutral governance for your open source projects. Like I'm mentioning, is the most popular open source project in the world. Of course, everybody has heard of Kubernetes. That's the second most popular. And plenty of projects like Node.js, Hyperledger, right? So Linux Foundation is a non-profit organization, is a mother body which has it kind of looks at around more than uh, close to 1,000 open source projects in the world right now. Just to put this in a little bit of perspective, the kind of support what Linux Foundation gives to multiple projects around, so that those open source projects are up and alive and in growing. So many millions of lines of codes are added and removed. There's so many thousands of contributors across the globe. The beauty of open source is contributors from across the world contributed, and that makes it more safer, more innovative, and more faster to the market, right? So these are the number. I just want to put some numbers around a few things what Linux Foundation does. And we are also behind some of the most critical projects in the world across different industries and different projects. If you look through this screen, you will find one or more projects definitely you would have interacted with. Now, AI and data is AI. There's no seminar or conference where we don't talk about AI. It's a sin, right? We have to talk about it. If you look at AI, for example, PyTorch is an open source project. MLflow, which is quite popular. GraphQL, right? So we are behind some of the most critical projects in the world. Node.js, for example, and then you have, of course, Kubernetes is number one orchestration platform in the world right now. Talk about security, you have tools like Falco, and you have standards like OpenSSL, right? So we are behind a few of these most critical projects in the world. Now, what about the Linux Foundation education? Now, I mentioned to you that we are non-profit, right? We don't really, we're not profit-driven. We don't make money. But Linux Foundation education arm of Linux Foundation is the one which educates people. So through our free education, we have educated hundreds and thousands of uh, students and engineers across the globe. Through our community outreach, scholarships, certification, and courses, we ensure the learners have access to training and certifications they need to succeed in source ecosystem. Our goal is to ensure that you have access to open source talent that you need to achieve success. And the good thing about our courses are they are vendor neutral, right? We have a board of offerings, the free courses and paid courses as well, like instructor led and e-learning courses as well. And there are some express learning courses, micro content, which is going to give you like quick bites of understanding what things are. The good thing about our courses are driven or made by the community for the community, right? We don't try to sell things. What I mean to say, we don't promote a single technology or try to promote a single vendor. It's a vendor neutral ground where experts like you come together, design the outline, and put up the content which you think is going to help the community. Of the many courses what Linux Foundation offers, around 90 plus of them are free. We don't really need to really pay anything to learn. Of course, there are expert classes which are paid as well. But if you're getting started in your cloud native journey, now if you're coming from a traditional infrastructure, or if you're just getting started in your career, you don't really need to worry about spending top dollar to get world class training. I'm going to show you where to get that and how to get that. But I just wanted to bring up to you, like, hey, what Linux Foundation is all about, and what we do at the Linux Foundation education arm. I'm going to quickly talk about why we had today the Cloud Native Computing Foundation. Now, if I give you a quick backstory, uh, around 2013, 2014 ish, when Docker made containers very popular in the world out there. Now, the Google also had their very own orchestration platform. Behind the scene, Google was running your Gmail search on billions of containers a week, right? And that is the scale what they were operating at. And to manage this particular number of containers, what they had was they had an in-house system called as Borg and Omega, which were the platforms for managing Kubernetes. Now, when the Docker made containers popular around 2013-ish, now the guys at Google thought about it. It's like, hey, we have a very good platform. We should make it available and make it open source. So they took the lessons learned from Borg and Omega, and they renamed or created a new product called as Kubernetes, and they donated it to the world. So what they did is they created this Cloud Native Computing Foundation, called it as CNCF, around 2014-ish, and they handed over the project called as Kubernetes, which is right now the world's most popular orchestration platform. In other words, if I say it's a de facto orchestration platform for the containers, it's not wrong. And that's how CNCF as a foundation came into existence to support the growth and work of application, what needs to be deployed on your cloud infrastructure. Kubernetes was the first project. And as we see right now, we have evolved over the time. Kubernetes last year celebrated its 10th anniversary. We're in the 11th year right now. And over the time, in these 11 years, what started as one project has grown into more than 200 plus projects and hundreds of members and millions of lines of contribution across the globe. Now, CNCF as a foundation is under the Linux Foundation umbrella. So, like I say, Linux Foundation is the mother body, which has multiple other foundations under it. So, CNCF is another foundation which is under the Linux Foundation out there. So, if I just throw in few most popular projects of CNCF, of course, Kubernetes is the number one. And you might have heard of tools like Istio, which another speaker is going to speak about in some time. There are tools like Harbor, tools like Flux, and Knative, and OPA, Linkerd, plenty of projects which are popular and widely used in production. Now, that's a little bit about the CNCF. One of the most common questions I get asked, you know, by the engineers who are freshly getting started, or from the folks who are transitioning from a different infrastructure world, is like, hey, you keep talking about cloud native. What is this cloud native? Now, what do you mean by cloud native application, right? So the example what I give them most of the time is this. Like when you're building a car, for example, if you look at a very popular car in India right now, for all the tough guys, is Thar, correct? Like everybody loves to ride that Thar Jeep into your off-roading, right? That car was specifically built for off-roading, so that you can go climb mountains, do dirt racing, whatever you want to do. But having said that, I can also take my Swift Desire, what I have with me right now, and I can do off-roading. But that car is not built for off-roading. I can take my Swift and climb the mountains. There's no guarantee that I might cross over or I might damage my car. Maybe I climb the hill, I will not. But if I look at the Thar, it is specifically built for a specific purpose, that is off-roading. You can take the car and do what you can drive through the rough terrain, right? So think about cloud native apps. Think of that as a Thar. In other words, the apps which are built for the rough terrain. When I say rough terrain, the rough terrain of modern distributed cloud environment. Now I can take a Maruti and modify it, make it off-roadable, or build an application or build a car which is off-road ready, right? So that when I say cloud native, is the applications which are designed to run on the cloud from day one. Not like the traditional applications. You take them and try to make them hostable, try to make them resilient, foolproof. With we can scale them, try to make them zero downtime. Try to roll out with zero downtime and try to make them high available. Instead of building traditional apps, you build applications to be scalable, to be flexible, to be distributed. distributed and to be foolproof. That's what we call it as cloud native. In other words, the applications which are built to be ready and available to run on your cloud. So if I give you an example of scalable, meaning you can grow and shrink automatically based on demands. If I give you an example of resilient, it continues to work even if some parts fail. Like, you have a lot of microservices. One service fails, the whole application doesn't go down. Flexible is, it's easy to update, easy to deploy. Perform a zero downtime rolling update. You go from one version to another version without shutting everything down. Distributed, in other words, is like, running them as smaller components like microservices, which we often deploy them in containers. Right? So if you build an app this way, that is what you called as a cloud native application. Right? Just wanted to throw that out. Now let's look at the main reason why we are here, our certification and training journey. How do I get started as an engineer, and somebody who's getting started with the cloud native? How do I get started? But before even I take you there, recent survey conducted by this Linux Foundation research arm, which spoke to the engineers, CXOs of all the top 500 companies out there in the world. And this is what the survey says. Now, the question is, why do I get skill myself? Why do I get certified? Why do I need to learn something new and prove that I have the expertise in it? Is because around 75% of the organizations consider that certification is important when they recruit the new talent. Because these certifications, which are very hard to get, which are not easy to crack, kind of act as a authority of your knowledge. That's the advantage of why you need to get certified. And Linux Foundation certifications, as you might have heard or seen, they're not easy to crack. Most of the Kubernetes exams are performance based, where you have a set of clusters where you go do certain activities, and then then you get certified. And they're tough to crack, but the good thing about them, because they are tough to crack, you really need to know your stuff. And when you know your stuff and you get that certification, it acts like a stamp of authority that you know what you're talking about. So that's one of the reasons why you need to get certified. And if you ask me a question, why do I need to contribute to open source certifications? Sorry, open source softwares. Percent of the organizations what were polled, they said, hey, when we are hiring somebody, if somebody is already contributing to open source, and it's a proof that they know what they're talking about, right? It talks about their technical ability. And then when you're contributing to open source, what are you doing? You're collaborating with people from different cultures, different regions across the globe, different gender, culture. So your collaborative, it talks about your collaborative skills, which is very much needed in this highly globalized environment we're working right now. And it also builds your portfolio before you show up for your interview. Your profile speak for itself, that you've contributed, you know how to write your code, you know how to read, is what it talks about. So these are a few reasons why you need to get certified and why you need to start contributing to open source. Now, if I talk a little bit about Linux Foundation certifications, right? We are backed by creators and maintainers of Linux and Kubernetes. We are vendor neutral, and they are regularly updated for the real world scenarios. That's one of the reasons why our Linux Foundation certifications are quite popular. Now, if I take you through your certification path, like where should I get started? What should I do is the question what you have in your mind. If you're getting started around the Kubernetes ecosystem, I would say look at the beginner aspect of doing a certified cloud native associate, KCNA as we call it as. This gives you an get started of what Kubernetes fundamentals are, what are your container fundamentals, what is cloud native, what are different cloud native tools. It is a beginner friendly, multiple choice kind of a certification, which I would recommend if you're getting started with your cloud native journey, with your Kubernetes journey. And if you have a little bit of hands-on, like you spend around 6 months to a year working on Kubernetes, you understand, what's a cluster, how to deploy apps. And if you are from the, operations, DevOps, SRE kind of a role, I would recommend you to look at the CKA course, the exam, which really tests your knowledge around, how to set up the clusters and manage those clusters as well. But if you're from the developer background, look at the CKAD, the Certified Application Developer, which is more or less around 75% similar to your operator CKA. But if you're from a development background, it checks around your skills on application deployment, configuration, and using tools like Helm, Customize, and things like that. And of course, for the advanced and the security enthusiast, there is an associate security exam which is called as KCSA, which tells you, it talks about the security around the Kubernetes clusters, cloud native, and containers, which is an associate exam where you have multiple choice questions. And once you have your CKA, once you've spent some time, then look at the advanced course, what certification what we have called a CKS, which checks your under the hood knowledge of the Kubernetes components. These are few path, or this is a path I would suggest, like if you're beginners, start from it and then add on top of it. And of course, if you have all five of them, is where you become a cube astronaut as well, right? Now, this I wanted to give you a heads up around the certification parts. I'm going to take you towards your training roadmap. Hey, now that I am getting started in my career on getting looking at the cloud native stuff, and I do not want to really spend too much money. I don't want you to as well. Why? Because here is what a roadmap what we have. Right? It might work for you. It may not work for you. Well, it's a generic roadmap what has been designed, which kind of give you a jump start. So first week, you need to focus on looking at adding or brushing up your fundamentals. First couple of weeks, we would recommend you to take up Introduction to Linux, LFS 101. Now, if you go on to the linuxfoundation.org, if you go to linuxfoundation.org, and if you click on the training right there, it takes you to a training portal where you can make use of your email address and sign up to it. And that is where you buy courses. That is the portal where you buy courses or buy your certifications. But like I was mentioning to you earlier, we have around 90 plus now. I think it's close to 100 plus right now. World class vendor neutral courses designed available for free. So LFS 101, what you see on the right hand side, is an absolutely free training what you have, which is going to help you understand what Linux as an operating system is all about. Gives you a little bit of intro into different protocols we have, different CLIs and shell scripting. It basically builds your basics, and having a Linux fundamental basic is very important, because if you look at tools or technologies like orchestration tools like Kubernetes or container tools like Docker, they're all built on the fundamental Linux principle. In fact, Docker, the fundamental building blocks of a container is your C groups, is your namespaces, is your ch root, Linux capabilities, right? Of course, they all work on Windows as well. But what I mean to say is the fundamental building blocks for all of these technologies are taken from the Linux kernel. I don't want to be a kernel developer. I don't want you to be a expert, but I want you to know and have a little bit of hands-on when you're getting started, because over the time when you add on to additional technologies, it becomes easy. It becomes the base. And once you're done with that, look at the container fundamentals course, the LFS 253. It talks about various different containers fundamentals of how to build a container, how to run a container, how to build your own image, how to push to registries, and gives you a little bit of best practices and makes it easier for you. And once you have fair idea of what containers are, how do you break down the traditional application, a monolith into multiple microservices, and how do you deploy them? Of course, when it comes to deploying in production, we have a lot of other complexities with containers. What I mean is when you have a lot of applications, each microservice is, in other words, what we call it as a mini application, right? So when we have a lot of applications, microservices need to be deployed as a container, managing them manually is impossible. That's where our orchestration tools come into picture, like Kubernetes, for example, the de facto orchestration platform, and which helps you. If I break it down quickly, what an orchestra does, it's a tool which allows you to run your containers and keep them up and running on your production platform. Right? Like, for example, provide you auto replication, provide you auto scaling, auto replacement if something goes wrong, self healing, zero downtime rolling updates. All of these features, manually managing them is not possible. And that's where we make use of orchestration tools. We have courses like LFS 158, which is absolutely free, which teaches you everything what you need to know to write, to learn what Kubernetes is all about. Of course, there are additional courses, what you see, like 258 and 259. Those are paid courses, which will help you gain additional knowledge. But to get started with, if you look at the introduction to Kubernetes and look at the Kubernetes documentation, it's more than enough for you to jumpstart your career around Kubernetes. And once you have fair understanding of how these containers work and how your orchestration tools work, you can look at adding on to additional skills like how hosted Kubernetes services are deployed, or look at the infrastructure as a code. One of the popular tool, of course, is a Terraform. And then when Terraform went the other way, and a fork of Terraform was created, and we created something called as Open Tofu. I'm sure you guys have heard of it, right? It's a open source version of Terraform. So look at adding on to those skills. There are a couple of courses we have which tells you, how to make use of infrastructure as a tool course. And then once you have a fair idea around it, of course, you need to have a little knowledge around, how these things are deployed. Now, gone are the days where we manually deploy anything, right? Because we're talking about scale, we're talking about resilience, agility, and time to market. We don't do things manually. We make use of pipelines, right? CI/CD pipeline. So we need to add on to this another, I would say, recommend look at DevOps and the GitOps. We have the introduction to GitOps, introduction to Jenkins courses, which help you understand what these concepts are and how things are developed. And the cloud native ecosystem, observability plays a very key role. Now, when we had, for example, a large monolith application, which was deployed as one unit and run as one unit, I didn't really have to worry too much about tracing, observability, monitoring, and things like that, because the whole thing worked as one unit. If something is slow, the whole application is slow, right? But now in the microservices world, when you've broken things down and everything is deployed as different containers, now, if one request, for example, if you look at a microservices application like a e-commerce website, say front end can be one of my microservices, and then I might have cart, I have my ad service, I have my cart order placement, I have my inventory. All of them are running as different microservices. So request lands on the front end, and then it traverses through multiple different microservices, doing what it is supposed to do, and goes out through the front end. So if something is slow, if something is taking time, or we need to understand what is happening where. So we need to look at traces, we need to look at metrics, we need to look at logs. So observability plays a key role both from the security point of view, from performance, and availability point of view as well. So understanding tools like Prometheus, Grafana, tools like Jaeger, which helps you in tracing, monitoring, is a very important aspect of it. In short, we call it as observability. There are a couple of free and open source courses we have. Open telemetry as a framework we have. It talks about all of these, the three pillars of observability: your logs, metrics, and traces. And then once you have fair understanding of that, understanding security is fundamental, right? So when you are a developer or your infrastructure admin, building your applications or managing your infrastructure, without security, there is nothing. So there are plenty of security related courses we have, like mastering security with Kyverno. We have introduction to zero trust, introduction to Kubernetes security fundamentals. I would recommend you to look at security, because when you learn security, what happens is uh, when you learn how to deploy applications, you learn how to deploy applications, right? You're at the 10,000 feet view. But when you start learning security, you go under the hood, you understand the nuts and bolts of it, which makes you a better engineer and then helps you troubleshoot issues faster. So I always recommend everybody to take security seriously. And when you imbibe these security features while you're building your applications, that makes it more helpful for everybody involved, right? And then, of course, I would say in the end, look at the cloud native platform engineering. What we have talks about, automation and self service, and look at different tools we have, which makes your life easier. In short, so this would be a little bit of a journey. I will share these slides with the organizers, and they might share it with you. This is a framework what we have, which we recommend that if you're getting started, start slow, start with fundamentals, and add on to the additional tools. And of course, you understand that this will give you a platform where which you can build on top of it. There are hundreds and thousands of tools out there, different programming languages, but what the framework what we are suggesting right now is to get you started, give you a platform from where you can quickly adapt and move on to any other uh, courses or any other technologies you want to take over from there as well, right? uh, Said, any questions so far? Said, you think, I'm sorry, I can't see the Q&A box when I'm presenting. Any questions, anyone so
Uh,
far?
answers to the questions.
Awesome. And how much time do I have, dear?
Um, I believe we can take further 5 to 10 minutes.
Okay, awesome. I'm going to try to keep it simple. Awesome. Thank you, Sid. All right. Now, you can take a quick screenshot of this if you want to. There are plenty of free resources we have, courtesy of Linux Foundation Education. So the codes will land you directly. So if you want to get started and I want to understand what should be my learning path, of course, I showed you something, but there are plenty more to it. Hey, I'm a system admin. I want to become a cloud engineer. What do I need to do? So what we have done, the industry experts sat together and they said, hey, this is what we think is an ideal roadmap. So we have the career roadmaps, we have the learning paths, and if I want to become certified, what should I take? How, you don't need to start from scratch. So we have put across a curated. When I say we, it's vendor neutral foundation. So we have few journeys, learning paths for you, which is recommended path, right? So you can sign up for our newsletter, send out a weekly newsletter which keeps you up to date in what's happening in the cloud native world. You can follow us on the LinkedIn. There's a complete course catalog which you can scan up and then take a look at it. Of course, the QR code what you see here is your uh, free course out there, which gives you access to most leading technologies like Linux, Kubernetes, AI, cybersecurity, and all of them. And those are pretty much, awesome courses out there. Now, I'm going to conclude my talk in another 3 minutes because Saeed gave me like 5 minutes more. Now, quickly, I want to talk about a topic. How can I become a better engineer? Well, how can you improve yourself and the community and make the world a better place? Is by contributing to the open source. But unfortunately, when I talk to students from the top tier colleges, they kind of know how to contribute to open source. But when I talk to people from colleges, not from IITs and not from the tier one colleges, they haven't even heard of open source. So I thought, we should talk to you about generally just as an awareness of how to contribute to open source, right? We have a simple 8-step formula. There are plenty of open source projects in the world. Like if you go to linuxfoundation.org, you will find there are 1,000 open source projects under our umbrella itself, right? So I would say the first one would be to understand which project, what is that you're liking. And I also showed you a slide which had multiple verticals. We are across industry, across different platforms and technologies. Choose what is, what you like, what project you like to contribute, and go read the documentation, understand what kind of licensing model they have, like there is a permissive license or a weak copy left or a strong copy left. And because different licensing model allows you to do certain things, right? For example, if you have a permissive license like MIT or Apache, well, you can take it, you can write it, contribute it, improve it, sell it, and you don't have to return anything back as well, right? They only need you to acknowledge. So similarly, I would not go deeper into different types of licenses. That's a whole topic altogether. Understand what different licensing model it has, so it allows you, gives you a freedom of what you can do with your work, and then learn about the particular project, read the documentation and guidelines, and then join their project meetings, join their Slack, join their newsletters, so you get a fair idea of what this project is all about. And you cannot contribute to open source, I mean, my view, you can otherwise, but what I generally say is you cannot unless you don't know any tool how to contribute, right? One of the tool what everybody most commonly uses is GitHub. So get yourself a GitHub account, learn the basics of the particular platform, like how do I fork a repo, how do I create a PR, how do I contribute to upstream, how do I element. You have fair idea of that, clone a project, and then start deploying or developing into your local repository, and then make small changes. It doesn't need to be big bang, right? You can look at some typo needs to be corrected, some comment need to be added, some formatting need to be done to the code. as, and if there's an open PR out there, look at it, open issue out there, and contribute, and submit the work back to the upstream. Most importantly, remember, we are working across multiple different people coming from different cultures, right? So for you it might be offensive, for them it might be the culture. So be accepting, be more open and willing to take feedback. Sometimes people do get nasty, but generally what I've seen in the open source community, people are very nice. So be open to the feedback, keep updating your fork. This is one of the easier way to get started to contribute to the open source project. Now, where do I look at, how do I get started? I'm going to show you a couple of resources. Just take a screenshot of it. For example, if you look at the contributor.dev, it kind of shows you, different. Let me see if I can quickly open it for you. For example, like this, right? It kind of talks about different uh, projects and different need they have. So these are few open issues out there. And if you look at the tags, what they have, there'll be something like, hey, good first time issues. It talks about it is a bug. It talks about it's a documentation, or it's a bug, right? It's a feature what needs to be added. It kind of gives you a different view, and you can take a look at it. There are more than 1,600 open issues out there. And like I was mentioning to you, whichever project you think excites you, take a look at it, and you can get started with this. This is one of the example I wanted to throw it out there. Now you can also look at the GitHub CNCF. There is something for mentoring and something for students. There are plenty of resources out there in these repositories which talks about how to get started as a mentor, as a mentee, as a student. Things are there. So a few things which will be definitely very helpful for you. And coming back to the last slide of mine, when I talk about contribute to open source, I talk about contributing as developer, but there's plenty of things what you can do as a non-developer as well, right? We saw on the website right now, there is this documentation which is ever needed. If you look at the Kubernetes documentation, it's pretty cool. It's pretty awesome. We have the documentation translated into 15 plus languages. There's a Bengali version of it. There's a Hindi as well, right? And how was that possible? Thanks to people like you, right? There's always testing and reporting of bugs. There's designing. We're always short of artwork. There's localization and translation, like how Saeed and team are doing the community growth and mentoring, the content creation, and then organizing events, sponsoring outreach. There are plenty of things what you can contribute to open source project, being a non-developer as well. So I would recommend, do not wait, get started to contribute to open source community, and let's make this world a better place. And with that, I'm going to uh, end my talk. Over to you, say thank you. If you have any questions, I'm open to.
Thank you so much, Raman. It was indeed a great session and a very insightful talk for pretty much everyone in this session, no matter at what level of professional life they are, indeed. And that is something I very much wanted to have the very first session of the very first meetup of 2026. I think it's very fruitful. Thank you so much for your time.
Yep, you're welcome. My pleasure. Thank you.
Okay.
I've given the screen share back to you.
Yeah. So moving forward with the very second talk of the day, and we have Rudra Madhav Mishra here with us, who's working as a cloud engineer at Amazon. Um, a brief intro about him. He has been working as I already mentioned, a cloud engineer at Amazon, and has a background in electronics and telecommunication engineering from Veer Surendra Sai University at Technology Burla. Of technology at Burla. He brings prior experience as a SD DevOps at iServU Technologies from Bhubaneswar, Odisha, and is passionate about open source and web development. He has actively contributed to developer communities, serving as a technical team member with the Microsoft Launch Student Ambassador Standings community and the Idea Innovation Cell. Uh, here's yeah, Rudra, the mic over to you. Thank you so much.
Yeah, thank you, Syed, for the great intro. Uh, I think I can share my screen now.
Yeah, you should be able to do it now.
Okay. Uh, can someone confirm if is it
Yeah,
visible?
yeah, we are able to see it. Yes.
Perfect, perfect. So yeah, I think Shahid already gave too much intro about me. Maybe I'm not that great, but let me introduce myself again. So hey everyone, my name is Rudra. You can call me simply Rudra. It's a big name, so let's make it short. So I work as a cloud engineer at AWS. If you have heard about AWS, so AWS has different services. So I work as one of the cloud engineers as that. You can connect me via LinkedIn in through this QR code. I will also share it at the end. So coming back to the point, I'm not speaking on behalf of AWS as it's a CNCF community. We will keep it as my personal views and experience so far. Moving on, here's a quick agenda what I'm going to share. So I will walk you around like Kubernetes and gateways. So we will understand what Kubernetes is, what gateways are, and we'll then walk around service mesh, what's a service mesh, and how Istio communicates with Kubernetes, installation of Istio, and how multiple Kubernetes can be associated in a single service mesh. So we'll get all through that, and at end I will also walk you around MTLS. So yeah, so that's a quick agenda for today's session. So I hope you will all will enjoy and maybe learn something. Even I can learn from you. So yeah, let's move ahead. So moving on, I will give you. I hope most of them are aware about what Kubernetes is or what Docker is. But if someone is very new, very beginner, then this session is for you. So to start off like how container orchestration came and how Docker started and Kubernetes started, I will keep it very simple and basic. So when we had an application, like for example a web application or a full stack application, when we had something of need to ship it as small as we could, so we used Docker for the same. Basically Docker was the best way to ship as a container, basically as an image to the publicly for like using it for further purposes. So for like as I said, like maybe a web application, can it be shipped as small as possible? So it was converted as a form of image, which is like you use it as a Docker image right now. And somehow like for example in a bigger organization, imagine like there will be lot of such containers as a Docker images, so maybe thousands or hundreds of them. So like you won't be able to manage lot of such microservices or those images basically. So you will need someone to orchestrate or manage these of the containers at a broader level, right? So this is how the orchestration or the management of entire lot of microservices or lot of containers came. So that is what container orchestration is. It is basically management of large number of containers across multiple places, and which ensures high availability and gives you a lot of control over all your containerized applications. So the best example of such container orchestration management tools are like Kubernetes, or even something like Mesh OS is also there. But Kubernetes is widely used, and how we are developing the community so far in CNCF as well. So Kubernetes has been rapidly used by various organizations, as well as they have been widely expanding it by making improvements with a lot of versions. So now we will slowly get to know how that works and all. So of course, like uh, you realize that if you forgot something in the Docker file, if I've ever written a Docker file, basically what happens is you give ports, right? For example, you want this application to be run at this container port, right? If you maybe put a wrong container port and you are running the application in something else, so you could get a error, right? So basically try to be more efficient on what we are writing on the Docker file to containerize the image, basically containerize the application, so to run as a image. So moving on to Kubernetes, as I said, is the one of the best ways to orchestrate containers, right, and manage multiple containers at a time. So it's an open source orchestration platform, which was initially developed by Google. Then it came to CNCF. Now CNCF entirely manages Kubernetes as an open source platform. And there is a concept here in master and worker node, we will get through as an image, or I will show you virtually how it works exactly. And here what happens is there are multiple microservices which are running as a pod. We will get to know what pod is, what containers are. In fact, a lot of people might be having doubts like, I don't know what's container, might be I don't know what is a pod. So we'll get through that. So here's a brief image which can explain you how exactly things work inside Kubernetes. And for example, this is a cluster, and you can see like there is a control plane, and these are few nodes aside of it. So what happens exactly here is like basically when a control node is exactly control plane is the you can call it the master, or the everything basically, okay, which manages a lot of worker nodes under it. So you have in control plane we have etcd, which is basically a key value data store, and it basically uh, no just manages data as a database. And we have scheduler, which basically schedules the pods. And we inside the worker nodes, aside of the control plane, we have nodes, right? So inside nodes we have pods. And what are pods exactly? And when I was learning Kubernetes, I was really confused that I don't know how, if container is inside a pod or pod is inside a container. So it was that confusing for me. So to give you a clarity, what basically happens is when we ship something, when we basically containerize the entire application into an image or form of an image, basically that's a container, right? So in Kubernetes, we have pods. So inside these pods, those containers of your applications are present, right? So inside pods, there are containers. I hope this doubt is at least clear for now. And so we have like in worker nodes, we have those pods, and basically these pod contain your containers. So of course now these pod are responsible to run your applications, right? If some pods are going down, that means some of the applications are not working, or it could be some any other error as well. So yeah, this is a brief architecture of how Kubernetes work. I've been I tried to keep it as simple as I could, because might be if someone is very new, that could be a little bit overwhelming, but I'm trying to keep it as simple as I could. So moving ahead, if you are very new to Kubernetes, you can, Minikube is something which is open source. You can try to create a cluster of yours. So we call as Kubernetes as clusters, where nodes are inside those clusters, as I explained in the architecture. So, you can start your creating your own cluster by using in downloading Minikube. You can go down in the Google, and you can search Minikube. You can find it and install it. Then you can start in the terminal Minikube start. Then you can go ahead and create your kubectl first deployment. And of course you must have already prerequisitely created your Docker images. Though Docker images will be in the form of basically the smallest form of your applications. And then you can see if it is already deployed after pushing this command kubectl create deployment. You can see like what are your deployments, and you can manage and control everything. You can get inside a pod, what's happening, you can check everything. And of course, to externally, if you want to show it to someone, like, yeah, this is something that I want to expose it to the public. So basically you expose your deployment as a service for a specific port, right? It could be a node port, it could be a cluster IP, whatever you want to actually expose, maybe a LBIP. So this is how as simple as it could be deployed in Kubernetes, right? So it has various applications. I'm not going too deep into it, but if you're someone as like as I got information, like as I could, it could be as simple or beginner friendly as possible. So I'm trying to keep it as simple as can. So yeah, so this is the basic way you can start off with Kubernetes, and start your first deployment if you have not ever done. If you're already a beginner, I mean already someone who is experienced with Kubernetes, yeah, you know all these steps, right? So this is how we create deployments in Kubernetes. So what will you get after for these commands? Basically, if your application name was hello node, you will have one by one pod ready, right? So one by one means basically one out of one pods are ready and available. So basically what you can see in this image is like we have an entire node, which is the this octagon or hexagon shape basically. So inside those node, we have pods, and inside those pods you can see we have containerized applications, right? So which I explained in the architecture part. So basically this is what happens inside the Kubernetes. Although who are already experienced with Kubernetes might have already known this, so you can bear with me a little bit, and we can move ahead now. Moving on, Kubernetes loves me, but sometimes what happens is if you get a simple error also, it could take hours and hours to solve, and this is what Kubernetes can be. But thanks to Kubernetes documentations, so they are widely updated, and people are contributing a lot to open source, so you can get resources documented everywhere possible. Okay, right? So if you are actually scared of Kubernetes, so don't be, and start off as no start off with the contributing, like with a simple deployment first, and if you're as beginner as possible. Okay, so yeah, moving ahead, talking about network policies, right? So I mean, like, if you have ever heard about networking, so what is happening, like contributing, I mean, communicating between service to service. It could be contributing with one microservice to the public IPs. It could be something like externally exposing something, or you can communicating internally. Networking could be in various ways, right? So what does a network policy define basically is, it defines the ingress and egress rules, right? So what ingress is basically the incoming traffic, and egress is basically the outgoing traffic, which is going from your pod to external use case, and for ingress, which is incoming traffic, which is coming from outside into the pods. As simple as that. So network policy resource, basically the pod selector, basically which pod is actually contributing for a particular service, and namespace, basically which namespace is it in, and of course it's optional, and which are the policy types, I explained it. And there are also a few CNI plugins you can explore, which is Calico, Cilium. I think there is some session on Cilium, I guess. So I think you will also cover that. So I believe example of how networking policies are Kubernetes, and you could explore them out. So here's a basic example of a network policy. I tried to put a simple screenshot of the AYML file, which is possible for me. Like you can see here in the spec, if you see the pods policy types, right, which is ingress, egress, and you can see inside the ingress block we have IP blocks, which is the CIDR range, and we have expected, we had excluded particularly a IP which we don't want, right? For example, this 172.17, this IP actually I don't want to get inside my pod, right? So I have blocked it. So we have tried to block this incoming traffic from this particular IP. You could do this in the network policies, right? So yeah, that was a basic and simple example of a network policy. Moving ahead, we will also know about, if you have heard about gateways. So what is exactly a gateway, right? A gateway is basically nothing but, if you have ever heard about communicating your service, your microservice with the external world, so you would need a gateway, right? So this gateway will basically intermediate, or something, a barrier which could actually cross to the external world in either ways, right? As vice versa, it could be responsible for the incoming traffic as well. So this is how something a gateway looks like. I could show the documentation at the end as well. I have put it here, but I will share it you again. Basically, it is the Kubernetes Gateway API. If you have ever heard about, you can check the documentation. So basically, what happens here is basically we give a host name. For example, you have hosted your site something like www.example.com, and we have few matchers, right? And we could actually put, for example, we have a e-commerce site, and we have login, sign up, different type of endpoints basically. So we can give them as a path, and this user can actually get routed to this particular backend when a user hits login, the basically www.example.com/login. And he hits that, you can basically route to the backend which is referenced in that particular port. right? We will actually know how Istio is actually helping as a service mesh in this entire scenario, and we will know what is a virtual service ahead and how actually things are getting done when we are routing a particular service. Because I explained earlier that there could be multiple microservices, right? So for example, login is a microservice, and you are expecting sign up also is a microservice, right? So let's say these two have different services. How are you actually helping them to route to that particular service? We will get to know, and how we are using or utilizing the Istio concept there. Okay. uh, Before that, going to moving to Istio, it's important to know like what is service mesh. So basically, service mesh is basically nothing, just a dedicated infrastructure layer above the microservices architecture, which is helping you to communicate with each other, right? So if you have ever heard about monolithic architecture, so there was like one service, and if the service goes down, everything is down. Mostly monolithic architecture was something like that initially. But monolithic architecture is also used in a lot of companies right now as well, because they are modifying their coding layers in different structure. But let's not get into that. But moving ahead, most of the companies use microservices architecture. So something that I explained, that there could be multiple microservices, right? To manage these multiple microservices, we discussed about Kubernetes, like how Kubernetes helped managing a lot of microservices. So service mesh is a layer above that, and it will be managed. It will be responsible for their communication between each other. How we could actually the features could be like how it could be managing the traffic, basically the routing that I explained just now, and retries, timeouts, something like security, MTLS, and something like observability, as well as authorization. Even there could be a multiple fault injection, or could be something like rate limiting. We will get to know all of these features in above slides. Okay. Moving ahead to Istio, which was one of the most anticipated thing, right? So Istio is a very popular, a CNCF, you can say a tool, like which is open source service mesh, which extends with basically Kubernetes, and it allows those traffic networking communication. And basically, Istio has a thing called a sidecar, right? So how and what does a sidecar do is basically sidecar, which Istio uses popularly, is Envoy, and which Envoy does is basically it proxies to all the service traffic, and we have various policies that could be implemented there as authorization policy, authentication policies, and there could be various things like which makes the system more reliable. So we are using Istio with the service, I mean with the Envoy proxy as a sidecar due to these reasons, right? So to making it more powerful with traffic, with the security purposes, as well as basically what Envoy does, we will get to know here. As an example, if you can see this this bullet, if you have ever seen this kind of thing, which was in, I think, 90s, I think, which had this sidecar. Okay, so someone can sit maybe aside of the bullet. So basically what happens in Envoy is just similar to that. Okay, it offloads the traffic, it offloads the entire load of the Istio to the Envoy proxy, and that is how a sidecar exactly works, right? It basically placed as an additional helper, which is like next to your main application container, which actually offloads the traffic and helps to utilize all the incoming and outgoing traffic with ensuring some security policies which can be applied, some traffic rules, and even it can call basically we when we something gets wrong in Istio, we generally go to Envoy logs to check if something is wrong with incoming traffic, if some other traffic is coming in, if something is not working as expected. So we could check those logs in actually Envoy, right? So this is how Envoy is as important as it could be for a Istio kind of service mesh architecture. Yeah. So this is what basically Envoy, how Envoy works inside Istio. Moving ahead, basically when how Envoy plus sidecar actually works together, right? So if you can see in this image, right? So a client whenever he's requesting into a Kubernetes service, right? So there is like a service A in the image, and there is a envoy proxy attached to it, right? So this is how they work it together. And when a pod starts, Istio basically injects into that envoy sidecar, right? And it applies all the routing rules, security policies, right? So now we will know how these services work together. Like there are virtual services, there are gateway APIs, like how gateway is created, how a virtual service is created. So maybe some beginners could be like, we don't know exactly how gateway is, what gateway is, how gateway is created, how virtual service actually work. We will get into that. So if anyone has, Istio, we everyone gets a sidecar proxy, right? Everyone gets an envoy. Okay. So coming back to installation of Istio, starting off, you can go to Istio website, which is, if you can search in just Istio, you will get the main website in Google, and you can use the demo profile to download and use Istio with Kubernetes. So these are the commands which is exactly explained in the documentation. You can go and check this out, which is the Istio. You have to install Istio first, and then you can install a demo profile if you want to get started off. And it's important to enable Istio injection. So basically what Istio injection does is like it will help you to inject the envoy sidecar, right? If it is disabled, you won't be using the envoy sidecar basically. So this is how you could start off with its installation of Istio. You can take a screenshot. These are the documentation links that I have shared. So this is the basically the link of the documentation where I took a screenshot of this. Moving ahead, you know, keep on googling stuff, because all of these documentations are widely available in Istio. So it is quite open source. So people do contribute in those documentations, as well as implementing various versions of it. So just check them out in the documentation. You will can find most of the things documented already, which are the commands or how you can get started. I just gave a basic example. You can start off with following this in the documentation. Moving ahead, I explained what a gateway is, right? So how you can basically create a gateway inside Istio, right? So this is a simple YML file where you can put your kind as gateway, and I have named it something like XYZ gateway, right? So, and we have given a selector as ingress gateway, and we have a host, right, which is the our website's DNS name, right? So for example, it is xyz.com. So I've given the host as xyz. If you are doing a HTTPS request, this could change to HTTPS protocol, and you can put the number as 443. But if you are doing HTTP request, which I'm doing right now, which is like we can keep the port as 80 and protocol as HTTP, and give the host name, which is way important, because this is how the gateway will work inside your DNS in a host name basically. Next will be the virtual services. So I explained that there will be multiple microservices. For example, there is a sign in and there is a login, right? We have two different services for a sign in and a login application, right? So you thought to manage it differently, because let's say if sign in application is down, someone could actually log in, right? Someone won't be able to just sign in, but actually they could be easily log in. If already the sign in application is down, people should be also able to log in, right? You don't want both of them to be down. Okay. So eventually you want everything should be up and running, but in just in case if something goes wrong, people should be able to log in, right? So this thing actually was the ideology of behind multiple microservices using inside Kubernetes, right? So now how you would actually route your backend. Like for example, the backend is that Kubernetes service, right? So inside those pods your applications are running. So how will you actually route or basically move the traffic which is incoming to those particular services or pods or containers eventually, right? So here we have the virtual service where you give your host name basically, which was defined as a gateway in xyz.com. So you are keeping the host as xyz.com and the gateway name which we defined here, which was gateway XYZ gateway. So we are putting them. And now as we are doing an HTTP request, we have the matchers, right? So this is called a matcher. Basically what happens is, for example, we have the website as xyz.com/signin. For example, if the user or any customer gets routed to this xyz.com/signin, this could actually move to those particular containers or pods which actually you created for that sign in application. And there should be a different you wanted to create a different login application, right? So this is how a virtual service could look like, where we are using two different matchers basically, where we have one prefix, you can put it as exact, or you would actually get the difference between what is a prefix and what is exact. I'm not going too deep into that, but what exactly is this prefix can get into /sign in /sign in dot, it could take anything, right? But exact will only take /sign in, that's it. So the destination is basically the service or the Kubernetes service which are actually routing to. So we have given if your Kubernetes applications exposed, right? I also explained how you can so if you're exposing the application for, let's say, 9090 port, you should put the port number here as 9090. And similarly, we have a different service for login. You can see there is a service A for sign in and service B for login, right? So we have two different applications, and for two different applications we are using two different prefix, and which are routing to those particular services respectively, right? So this is how virtual service can communicate between multiple Kubernetes services together, right, in a single YML file. So this is how multiple, let's say you have multiple microservices and basically multiple backend services, to be more general, and they could be routed to different prefixes or different endpoints basically through this virtual service file. Okay, I hope I could keep it more simple than as possible. Okay, so that maybe there could be a beginner joining in, so he could get all those concepts as quickly as possible, right? So moving ahead, there could be something like, if someone doesn't have a particular, let's say that he doesn't have a particular microservice or a particular port ready. He also only wants, something like, I have a IP, right? I have a IP. I just want this IP to be used as a backend in through this entire virtual service. So basically, you can introduce something called service entry. So service entry is nothing, just basically you can put a IP if you want. So for example, if you use Google Cloud, you will have Cloud Run. You can use any particular IP, Elastic IP, you can use them, or LBIP, because people do in maybe something like semi or mid-ranged company, they use a lot of services like this. So you could introduce them into virtual service through this service entry basically, right? So yeah, you can see like that could be little bit overwhelming, like people who are not actually too much experienced into these CNCF tools could find it a little bit overwhelming, but I feel like I could explain it as simple as possible, you know. So yeah, something definitely will left over if you are learning in DevOps. So there could be multiple tools, multiple experiences when people will be sharing, and CNCF community is growing as rapidly as possible. So many things are changing, many things are getting born, and you can actually take all of them at once. Take one step and another, and slowly get things done. And you can experience all of these tools by going into the CNCF documentation, where you can find all these graduated projects which are widely available as it's open source, and you can start using them, right? We just to conclude everything, I'm just going to also share more use cases of Istio, right? Something like, for example, you have a service, right? And you see something happened that you are unexpectedly expecting, no unexpectedly seeing lot of traffic into your service. For example, you expected something like 100 users, but something unexpected happened and you are seeing like 2000 users are actually using, and you don't want actually that to happen. and you are not prepared for the same. And so what could actually happen is you could put a rate limiting. So in Istio there is a concept called rate limiting. We can prevent the overload of backend services to basically throttle the incoming request. We can reduce it to certain number. We can also do retry policies. For example, there is a particular error that is expected to come in a backend service, and you don't want it to, like, the customer or a user to stop there and go back. Okay, so you want him to retry that policy and to retry those failed requests to the backend. So for that you can also put your retry policies, which are exactly available in the Istio documentation. You can go and check them out, and you can implement a retry policy inside your Istio document in your virtual service using this retry policies, right? uh, Last but not the least, you can check this authorization policy and MTLS. So what it basically does is, like, you can, if you are expecting something like authorization, for example, you don't want someone else to maybe use that particular service or the traffic management. You want someone with specific IPs. You want someone with specific, you maybe use from something like domain names. You want to categorize these things, and you don't want this mutual TLS to happen between something which is not known to you, and you don't want that some different attacks or kind of devastating happens into your service, right? So you can implement those authorization policies into your Istio, and you can make the best use of it as a security purpose, because security comes first. It's a priority zero always. And you can definitely try to implement all those authorization policies and mutual TLS connections, right? So yeah, go bold. Let's use Istio, right? And definitely I hope the session was interesting. I could try to keep it as simple as possible, because it could be a little overwhelming for someone who is very new. And yeah, go ahead, go use Istio. And I'm available for any questions. Over to you, Shahid.
Yeah, thank you so much, Sidra. I believe the questions would be able to reach out in the Q&A. Indeed, a very insightful session for Istio and for everyone who's pretty much new to Kubernetes and looking forward to learn Istio. And indeed, there's something else I would like to add, that there is another mode of operating for Istio, that's ambient mode. I would like to people to explore it. Yeah, thank you so much, Uddhav, for the talk. Indeed, Sunday morning it is. Thank you so much.
Thank you, Shahid.
Okay. Moving forward with the third talk of the day, that is from V. Roshan Kumar Patro, who is currently working as SD DevOps and SRE engineer at Misho. He'll be talking about breaking cluster boundaries inside pod-to-pod networking with Cilium. A brief intro about the speaker. He has strong experience across DevOps, SRE, MLOps, and hybrid cloud, and a former AWS community builder. He is actively involved in cloud community and is known for sharing practical insights and building scalable, reliable, and cloud-native systems. Roshan, over to you.
Yeah. So, hello everyone. Glad to be here. Speaking on CNCF related projects and Kubernetes networking. So, before jumping into the basically deep components, I will be starting with smaller components with good explanation so that you can understand, right? So, let me share my screen. Is it visible? Hello.
Yes, it's visible.
Hey, you're audible.
Yeah. So basically, if you see my topic, like breaking cluster boundaries inside pod-to-pod communication with Cilium cluster mesh. So this will be a variantly good topic for pod-to-pod communication. As you saw from the previous speaker, he was wanting to connect Istio and basically the service mesh, right? So now what we would do is we would connect microservices between the clusters. So that will help basically connect the microservices, and if one service is there in one cluster, how will you connect to other cluster. And suppose if I'm calling one API, how it routes to another API in a different cluster. So that needs connection somehow, right? So that we will be doing via Cilium cluster mesh. So basically, before going anywhere into the Cilium or anything like that, we will jump into first the basics, right? So this is me, introduction from myself. I'm SD DevOps at Misho. I do contribute to infra components. I do the SRE stuff as well, including any of the things related to Contour, Envoy, basically node imaging, node packing, everything related to the DevOps, right? So also a chicken biryani lover, and I love to ride bikes. You can connect me in LinkedIn as well as in Instagram. So let's go forward. So if I ask you a question, what is CNI? So the simple thing in every related components, like every networking components in Kubernetes is controlled by CNI and its plugins. So this is where we can basically start. What is a CNI? So ever thought of key at the end of the day, you want to do what basically? So you want to get a container image, deploy it in your cluster, and make the container or the pod running. So basically, pod is an encapsulation of containers, right? So inside one pod, you can have multiple number of containers, and you want them to fetch the latest image, anything you have built of your code, then deploy it and run it. Then your pod becomes functional, or your container becomes functional, and the rest of the thing follows out, right? This is the every day end scenario. This is the simplest way of explanation what you want to do at the end of the day. So basically, how it happens is key. We do run use Docker, right? Docker, we heard about Docker anywhere else. So that is container runtime interface. So this what I showed you, right? The deployment into a cluster inside and making it to the pod running. That is carried by the CRI, that is container runtime interface. That basically helps you in pulling the images, running the init containers if it is needed, and starts the main container, application container basically. So if you take the examples of other container runtime interfaces like Docker, Rocket, Podman, Cryo, etc. So basically, this CRI works with any of the services related to GK clusters, container service, Amazon ECS. That is the basic functionality where the pod gets connected and pods get running. And then what? Do you have any idea how do you access the pod? If anyone can unmute them and speak out. So we made the pod started with the CRI, right? How will you access it? Okay, let me go ahead.
Roshan, just sorry to interrupt. The thing is, maybe you need to check the Q&A as it's a webinar mode, right? The participants won't be able to speak.
Okay, okay,
And you
fine.
need to check the
So if I go forward it, how do you generally access it? So here comes the result. So basically, we have the IP addresses of the pods, right? So IP address gets allocated to each pod when you run it. The CRA part is job is done, and CRI does not have any of the segment to connect and allocate the IP. CRI just makes your container start, right? So the IP address basically helps you to access the pods. Their image of CNI, that is container interface, right? So this what it is helping in giving the static allocation, IP address allocation, bridge mapping, and connecting it to the base network, right? So interface between any CRI and the network, it's not just for Kubernetes. Many people or many myths have key CNI means it is just for Kubernetes. So any container runtime interface can connect there, and via the CNI plugin to the basically the servers, right? So it configures routes and decides the static IP. If I show you this picture as well, right? Whenever the runtime happens, so basically the CRI calls it and tells key add me into your network. So that happens via this CNI. CNI helps in the commands like I've showed in the right. So basically this execute bridge plugin, IPv plugin, static plugin. These all will help in mapping the IP and the container into the network and allocate a IP. That's where you get the static IP or any runtime IP. So now, what is Cilium? Cilium also is, as we saw, ki Docker, Rocket, Podman, all those are a part of CRI, right? So Cilium is also one of the CNC projects which gives the networking, observability, and security for Kubernetes clusters. So what makes this difference is most of the Kubernetes clusters or any of the CNI does proxy routing. So proxy has the IP tables routing. Basically, it stores the IP tables where and which. Suppose if this IP comes, I will route it to this pod or this service. So that does not happen in Cilium. Cilium uses eBPF technology to route and maps the pod to pod communication and pod IPs via the network capturing packets. So basically, that happens instead of proxy, which eliminates the basically the what do you say, the scaling hurdles or the latency throughputs or the reduced latency throughputs which happens in proxy. Generally, if you see, proxy gives us a bit of latency. If you see the all around BAU latency around the proxy, it will be less more than Cilium. So that's why Cilium is more preferable because it works on network capturing packets and goes inside the kernel level metrics and deals with the connection instead of going via the IP tables management. So yeah, this is Cilium first. If you see the picture itself, via the plugin. So basically, Cilium is also works on plugin based. So any of the one who wants to connect it to the cluster, it will go through this CNI plugin and connect to the pod via this CBPF method. Level work is happening here. That's why here observability is also more because we have a detailed capturing techniques, network captures, and all those things. So everything is very good and enhanced way. So currently we can say that key we are entertained about that. Let's move forward. So what do you basically mean by intercluster communication or the pod to pod communication? So as I said, right, intercluster. So basically understand there is two clusters. You want to communicate between both of them, right? Why do you want to communicate? I will come into that later. But what is this basically? And pod to pod communication. Intercluster communication works generally because in many companies there are multiple number of clusters were handled by different workloads. Suppose data platform teams have their DP clusters, data science team has data science clusters. So you need to connect to services. Suppose I have one service that talks to data platform team service. I need to connect, right? So if I want to connect to that service, I need to first connect to the cluster itself. After the cluster I connected, then I can go inside that and connect the service, and then service will connect me to the pod, right? So that is what you mean by this intercluster communication. So now importance of communication, right? So if I open any of the pages in Meesho or in any of the pages in Flipkart or anything, right? So the orders flow is there, the cart flow is there, the checkout flow is there. So any number of flow you make it out. So there is various number of APIs which follow. Suppose manlo I hit the normal open the Meesho app and do the things, right? So if I hit the APIs, first it will go to the login page, then it will go to the basically sign up or anything like that, and then it will go to the viewing of the catalogs, and then it will go to the cart, then the payment section. So all these payment section, anything of that may be related to other clusters as well, right? As I said, your data science, data platform, supply teams. So everything is in a segregated way in companies. So that's where the importance of connection comes, and the connection of microservices comes, and that's how you deal with intercluster communication. So now we will talk about the cluster mesh or the cluster service mesh. So we will be connecting two clusters basically by Cilium cluster mesh. There is number of ways to connect your two clusters. It's like in GCP also you have MCS, multi-container service to connect. But now as we are going to Cilium, Cilium has a capability to connect two clusters. Basically, it will give you the high observability of cluster mesh because it has its own API server, etcet API server, and it manages its own database as well. So that's why it will make you deal with more observability and network metrics. So this is what to connect two clusters indirectly, reaching to pod-to-pod connectivity. If you see this, right? So basically this is one node. The pod gets attached to a cluster. This is one another cluster. These all connects via cluster mesh API server, as I spoke about it earlier, right? So API server gets deployed in both of them. Then via its LB, it connects securely. And when I hit connect to two clusters, that happens is in this side, it maintain its own etcet server. It maintain also its own etcd database server. So basically, they manage all the connection that and completely waiving off the queue proxy level of IP tables handling and all those stuff. So how these things work. So if you see also here, it also supports basically shared services connectivity. Suppose Manlo, you have Vault service in one cluster, you want different clusters to connect to Vault. So you have this vault here in cluster 2. Simple connection makes it possible. So these all use cases can be covered in cluster mesh support, right? So I will go through the deck once, the blog which I have written. So if you see here, before setting up the intercluster communication, we should have the non-overlapping port JIDAs in both of the clusters. So Manlo, we have two clusters. Their pod IPs or the pod ranges should not match each other or should not overlap in each other. If you see here, I have made this at 10.2.024 and this is at 1/24. Because if you overlap it, then Cilium does a overlay network mapping. There it will coincide and happen. Basically, it will bogus out. So after we have it, the non-overlapping CIDRs, so installation becomes easier. So if you go here, we have basically I did 3 master workers. I wanted to connect to this intercluster master and this master. So that I will to connect to both clusters. So what I did was key I first made sure key this overlapping CIDs is not there. Then the Cilium connectivity should be there, or like the in the master node Cilium CLI should be installed, and then the L3 network layer reachability should be there in the both of the clusters. Basically, L3 means the network layer connectivity. So if you see two clusters, right? Two clusters are given basically for different BUs, different purposes. Both of them will come under one fleet, one VPC, right? So in one VPC only, they should be able to connect it so that these connections can be made possible at the end. So that is what I meant by proper network connectivity within the cluster nodes. So after that, what I did was I made the configs, both of the clusters kube configs into one another, and I merged it. Then I basically set up the cluster IDs for itself for each of the clusters. So after that, what you basically do is command. If you check for status and to connect there is a command to both of the clusters. So if you see here, right, Cilium cluster mesh enable context cluster 1. So this is the cluster ID and service type is node port. So in both of them, if you do this and after that you will do the wait command, it will show you that cluster services is enabled and both of them can talk. So when you get this message is basically you can now interact with any of the services of cluster 2 from cluster 1. And if you ping any of the pod IPs of cluster 2, it will work. So that's how microservices needs to be talked, right? The use cases when I saw key, every microservices need not to have in one cluster. There is BU-wise segregation is there. So what happens internally is Cilium cluster mesh, it creates two components, etcd and the API server. All the components are handled by API server, the actual Cilium cluster mesh control plane. So what it does basically is it creates work And overlay network is basically a virtual, what you can say, virtual extension of the physical network. If you see this diagram, right? So uh, so this is the container, this is the CRI, and then the network components come into play. This is the physical network where the IP gets allocated. So this overlay network gets created by Cilium API server. This overlay network creates on top of physical network, so that the processes can be made via the connection. So how it does is basically the VXLAN, what I told you about the virtual extensive LAN, right? So basically, it creates the overlay networks between the clusters, so pods in two clusters can reach to the CIDR directly. Now, what is the difference between Kubernetes control plane headset and Cilium cluster mesh? Because it also decides its own headset database, right? As I told you earlier, it stores its own secret keys, the TLS configurations, which I showed you earlier. It stores all the details in here. And but the Cube proxy and the Cube API servers headset is different for different purposes. But here, Cilium uses its own. It does not rely on any of the components related to Kubernetes. So that's where it makes it special. And each of those get a Cilium agent installed so that they will be communicating via the API server. So after this gets installed, it will connect to API server, and then API server will help redirect to connect to clusters, and then to service, then to pod. Basically, this is what happens at cluster mesh. So there is a quick saying that key cluster mesh doesn't magically create the overlay network. It creates it very good via layer 3 reachability and the overlay communications. Basically, physical network VXLAN communications are there, and most of the CNI does VXLAN communications. They, if you see here, Flannel basically does VXLAN encapsulations, but internally it does some other techniques. But here, Cilium, it entirely depends on VXLAN, which I said you is the virtual extension of the overlay network. So if you do that and connect it, then basically you can be able to connect it to both of the clusters. So guys, this was some of the tips and tricks for intercluster communication with Cilium. And I hope this was not so fast and so big. Uh, I am open to Q&A.
Yeah, thank you so much, Roshan. I think with respect to time, we'll be moving forward with the last and final session. But in case if any questions do come up, we can definitely answer them through the Q&A. Thank you so much for taking the time to present talk, a great talk on CDM and the pod-to-pod intercommunication. Really appreciate it. Thank you so much. So again, thank you everyone for bearing till with us. It's coming to the very last session of the day. And that's then me. Hey, hi, I'm back again. Right. So yes, let's just share my screen right away. Yeah. So my session is basically reducing Kubernetes YAML sprawl with Crow. So as in, I believe two of the speakers, Rudra and Naushan, told I would very well versed talk on about Kubernetes and the service meshes Istio and Cilium. Pretty much great things indeed. A very high level, and I would say a very advanced level of deep networking knowledge would require for them to work on it and even present it in the first place. Indeed, thank you so much to both the speakers for presenting the introductory part of the Kubernetes and pretty much laying down the foundational concepts that needed for to get involved with this talk. So as in the people who have been working with Kubernetes, so YAML is something I would say in fact any person working with Kubernetes would say is very unavoidable. And as and when the application grows, the YAML piles up like anything, and so it becomes YAML hell as in even in no time almost as the application grows. So this entire talk would be about a project that is again a sub project of Kubernetes, Crow, and we'll see all the details. So moving forward, before getting started, a bit of about me. I already did introduce, but coming again. So I'm working as a DevOps engineer at Convin.ai, and I'm Kubestronaut, and of course the co-organizer for the Cloud Native Bhubaneswar. And I pretty much hold 20 plus industry recognized certifications across clouds, Linux Foundation, CNCF, and Google Cloud and AWS. Yeah, so that jumping into the agenda of the session. So we'll first see about the Kubernetes YAML sprawl, the main, I would say, the problem that we'll be solving with Grow, and we'll see the traditional approaches that we have been using for deploying the applications in the Kubernetes cluster, and then we'll be right. And then we'll be seeing about Crow, what is Crow, and how exactly does it help in reducing the the YAML footprints that we see as in the application grows and we have all resources and YAMLs showing up. And then we'll see about server-side resource management with Crow. How does Crow and helps in solving this use case? And we'll see the platform engineering benefits that the Crow provides with its you know features. Then we have a small demo of the same. I pretty much like to present demo in pretty much all of my talks, and we'll have the key takeaways. Moving forward, the problem Kubernetes YAML sprawl. Okay. So as and when we develop new applications, or maybe as we break down the monolith architecture, we have a number of microservices running out there for which to be running efficiently as part of the application. We have multiple Kubernetes resources that we are supposed to deploy, maybe starting from a Kubernetes deployment, a service to expose it internally, or maybe an ingress to expose it externally to the clusters that the users can be able to access the workload application. So so a lot of resources piles up for a given application to be running, maybe a PVC out there for a stateful set, right? So a lot of resource dependencies comes up when the application grows. And we do have multiple environments for the application, right, from dev, maybe QA, staging, and then prod, right? And the issue comes up when the developer who is pretty much responsible for building the applications gets involved into learning about Kubernetes and the YAML structure of how to deploy a given application, because even a single indentation would make a lot of error and may cause a break in the pipeline that is done applying the YAMLs, right? And the complexity grows, like undoubtedly as the application grows, the number of resources to be deployed becomes more and more complex, more and more, I would say, included with minor details such as maybe the scheduling effect of the scheduling to be governed by taints, tolerations, affinities, which are, I believe, shouldn't be a concern for any developers, right? It's primarily for the platform team, maybe for the DevOps and SRE engineers who should be primarily responsible for uh, these infra-related tasks, and developer at all not at all should be even allowed to make any changes, because it again would clash with the entire infrastructure, right? So this happens to be the problem, as in the number of I would say flags that we want to enable in a YAML, it grows and it becomes much more complex to maintain. So we had been using the traditional approaches, and we'll see about the limitations. Primarily two tools that we have been using, Helm and Customize. So both of them are client-side implementation. As in client-side, I mean the YAML that is supposed to be applied is generated right at our end, and it is then supplied to the Kubernetes cluster, the API server. So what advantage or disadvantage does it give? So I believe the only advantage that we see is we can see the live YAML that is supposed to be getting applied to the cluster, and maybe it would be like thousands of lines for a given set of applications, and sometimes it's pretty much overwhelming to see such long YAMLs and to be easily able to interpret it, right? And Helm, pretty much you'll see the key differences between both of them, Helm and Customize. It's Helm is completely based on Jinja templating, right? So a person needs to be well versed with Jinja templating and also with the YAML structure. Uh, it's pretty much very complex for I believe for the persons who have been handling Helm and customize, specifically Helm. So the YAML, the values of YAML files can grow anywhere from for maybe any application from hundreds to thousands of lines, given if there are a number of resources to be there. And limited validation, of course, the validation process is something that gets pretty much very low importance when using Helm. There is as such no validation when the YAML is generated, unless when it is applied, you see the error that well, there's a validation error. And of course, very hard to enforce guardrails consistently as because of the validation process. Coming to customize, people who have been using customize, although it pretty much also reduces a lot of YAML, but again, depending upon the patches that you apply for a given environment or maybe for a given use case, it again somehow leads to growing of the YAMLs. Yeah, of course, as I mentioned, still requires managing multiple manifests and no strong abstraction boundary for developers. At the end, they still have to, understand the patch strategies and all sort of stuff that they need to know in order to use customize, in order to create any manifest files to use customize. So that would be the pretty much the client implementation that we have been using as of now, right? Moving forward, so we'll see how Crow comes up as a better alternative to all this current implementation of Helm and Customize. So Crow is basically a sub project of Kubernetes SIG cloud provider. This project aims to simplify the creation and management of custom resources for Kubernetes. Right, you can go just on this official website, that's crow.run, and know more about it. So we'll deep dive a bit into the Crow. So how does basically Crow help? Crow basically stands for Kubernetes Resource Orchestrator, which is self-explanatory. It brings a high-level resource blueprints. It creates an abstraction for the developers or maybe for the end users, that the ones who will be building the YAMLs. And it has a server-side resource orchestration, implies the YAML, the exact YAML that is supposed to be present, the exact deployment that is supposed to be created is rendered at the server side, and we just need to provide only the details that we suppose, such as just we are as a developer, maybe I should be very concerned about the replicas. I shouldn't be concerned about the node selector or maybe where does this application run in the infrastructure. I should be only concerned about the name convention that I want to give, right? So that sort of abstraction is completely supported by Kubernetes Resource Orchestrator. And opinionated default with saves overrides. So the concept of default values is although present at Helm, but again, that is something is not pretty much readable when we actually go through and read through it. So that is something very easily possible and in fact implementable when using Crow. And lifecycle management as a unit. So when it comes to lifecycle management, what it does mean basically is uh, there is an application that has been very newly introduced, and the developers or maybe the platform engineers are yet to leverage the full-fledged version of it. So with time it grows, with time we understand the resource utilization with and what all resources it needs, right? So that is basically pretty much termed as the life cycle management of the application, and it will be pretty much very easy when using Crow. We'll definitely see about it. What does the life cycle management mean? And goes hand in hand with GitOps, right? So at the end of the day, Crow is also using YAML, of course, because it's native to Kubernetes itself, but it would give a very high level of abstraction, and that we definitely get to see in the demo part. And as it's a YAML, definitely it goes very easy with GitOps for the people who have been implementing Argo CD and Flux CD may be very well aware of the term of GitOps. GitOps basically, if I would give an overview, you basically need to uh, keep the manifest, whether it be a plain manifest or customize our hand in a Git repository, and connect the GitOps controller, maybe a Argo CD or maybe a Flux CD, with the SCM tool where you have managed the manifest, and you just keep making changes and in the repository, and the controller running in the Kubernetes cluster would sync up with the actual desired state of the manifest. So basically, this overall is the concept of GitOps, right? So that's and Crow is pretty much very good with GitOps, right? So we'll now start with the deep diving of Crow, how Crow reduces YAML footprints, right? As I already mentioned, it defines a very high level abstractions. And what do I exactly mean by it? We'll definitely see that in demo. And one of the key use cases, suppose we have an, as I already mentioned back then, suppose we have an application, a front-end application that is running in maybe static front-end application. It requires a deployment to be present, maybe 2 to 3 replicas or a service to expose it internally, or maybe an ingress that is supposed to be created. And let's have an instance that we have with on a daily basis or maybe on a regular basis, you have a given number of applications that comes up, and you always have to create these three resources, and that's becomes again a YAML hell, right? You have to have YAML for all the three of them: the deployment, the service, and the ingress, right? So it's completely repetitive thing. Of course, again, that is something people have been doing using Helm customize, creating patches, folders, and values that YAML file depending upon the environment or use case, right? So we'll see how Crow basically groups them all and pretty much eliminates the boilerplate of the YAMLs. Just maybe you need to not mention the kind again and again. The labels letters not need to be mentioned again and again. Maybe the port numbers need to be very easy to be mentioned instead of having 4 lines for a port to be present, right? So what it results as the abstraction in place, the YAML that is supposed to be actually written by any developer on a DevOps team is reduced by a lot. We'll see definitely how it gets, the YAML gets out completely and just very simple details out there to be presented. So for the people who have been running Kubernetes, you definitely should be aware of the concept of CRD, custom resource definition. So Code does a pretty similar thing of having a resource graph definition, wherein you define the application subsets, such as maybe for deploying an application requires the three things about it. Maybe it's a deployment, a service, and ingress. You template it out completely for once, right? And as you can see from the screenshot itself, you can maybe pretty much give a default value, and for a given deployment, you must be very concerned about just the replicas and not any other considerations in place. And maybe for ingress, again, it's pretty much optional. If it's enabled, it will create one, and it can be disabled. So we do also have the feature flag process in place as well. In case if you want it, it will get created, or else it won't get created. So you here what you do is basically define a template of how your custom application looks that would deploy its dependent sub resources of Kubernetes. Right? If I can give you a overview diagram. So what you have done here is you have created a custom resource called application instance, right? So basically that would manage deployment, service, and ingress. So instead of you creating these three YAML separate, you just need to just write only this much of YAML, which would create a deployment and the dependent service, and then the ingress if present true, or else the default value is false, as you already see, right? There is a default value of false in case you provide one, so that will get created. So you can see if the people who have been using Kubernetes, you definitely know what length of YAML you would write for creating a deployment, for creating a service, and then the ingress, right? And even that being said, there is a very high probability of making mistakes when giving any sort of maybe a annotation, maybe a label, right? So these are things that are very prone to making mistakes, and human mind, of course, we cannot blame it completely. We are not perfect beings, but when the things get abstracted, the probability of making an error reduces to like next to nil, right? You just need to provide the name, the image that is supposed to be getting used, and the replica. So you can clearly see how what amount of YAML has been reduced to, right? So that's what we do exactly. We define the template of the custom kind that we will be creating, that is application, and we group the resources that we want to be present when an application is created, right? So it is completely, so that's how basically Crow works. And there will be controller Crow of Crow running behind, I mean running in the cluster, that would ensure that a given deployment is running, the given replica is created, and the given ingress is created. So it's the responsibility the way pods get deployed for a deployment, right? You create a deployment, but it is, as a result, the pods get created. The same way, Crow works with the same principle. You define the uh, resources that is supposed to be created when you create an application. Here in our case, it's a deployment, it's a service and an ingress. So as soon as an application gets created, as mentioned over here, the three sub resources also gets created. And as I already mentioned, the YAML has been reduced to almost like some 10 to 50, I believe it's, yeah, so it's just 10 lines. And on average, if you create a deployment, it's no less than 20 lines mentioned as such. Right. So again, as I already mentioned, Helm and Customize is something that's completely client side. The entire YAML gets rendered locally, and that's how it works basically. So we'll see the server side resource management with Grow. So how it is beneficial for us. In fact, if we just follow, we have created templates and we create this application with our required, sub resources. The YAML footprints is decreased to a lot of, like, it's completely immune to the mistakes that we usually make when we create an YAML locally. Maybe a helm that generated the YAML, it may would have some indentation issues, possibly maybe through customize as well. So that is something we face issues with, right? When we generate it locally, client side rendering, that is something I wanted to mention. Harder policy enforcement, because if given, so as such, there is no restriction when we generate it using Helm and customize. Limited restrictions, but yeah, still very huge possibilities of making mistakes. Limited life cycle control, as I already mentioned. Life cycle is something very hard to control when we use Helm and customize. And tool specific logic, right? So for using Helm, you need to be well aware with the Jinja templating and YAML. And customize, also you need to be very aware of the the commands that the strategic patch merge, the structure that we need to present the patch with. All these steps are we should be well aware with in order to use customize. Coming to Crow, it is rendered in cluster, as I already showed. So you presented the YAML that is present for the Crow for deploying all the three sub resources. It's very tiny, in fact, compared to all the actual YAMLs. Native policy integration, as you are responsible for creating this one time, right? This is just a pretty much one time effort. And with your each application, what you do is basically you create this small objects of it, and it's very easy to handle. Full life cycle orchestration, because everything is again YAML, so it's very easy on your part to be able to add any features in this, or maybe some other dependencies option, or maybe a required dependencies to be present. Easier to manage life cycle. It's because at the end it's again native to Kubernetes. Yeah, you already mentioned Kubernetes native. So how does it help? So at once a crow has been implemented, what it does is it maintains a clear separation of concerns of who is responsible for what parameters in a given workload, right? The platform team defines abstractions. I'll cite an example. Suppose there is a given set of workload that needs to be running on a given set of nodes which have their own taints and tolerations, and the workload also taints, and the given nodes have the taints and labels, but the developer need not to be aware of what exactly he or she need to mention. That sort of abstraction can be created with the platform team. That a given workload, no matter what is having the name or maybe the replicas, is supposed to be running on a given set of. So they'll just create an abstraction of having the tolerations and the node selector maybe or affinity. And the application team is just supposed to give the name and the number of replicas that is supposed to running, and then of course the image name. Right? That sort of abstraction is clearly possible using Crow. And developers need not need to be very well versed with the Kubernetes knowledge at all. Right? It needs to be aware of the YAML, how to write a very easy and convenient YAML file, and that would be fine for developers to get started with deploying workloads. And reduce blast radius of misconfiguration, right? Because there's a complete abstraction of what can be passed on to the Kubernetes cluster. The expectation of making a mistake also reduces very highly, right? So you need to mention the node affinity, and then if people must be aware of how, if you want to mention node affinity, how long it goes, like 5 to 6 lines of indentations or maybe a mistake, they're all gone. Right? Getting scheduled on the wrong node and resource getting used up, right? So that sort of blast radius that is supposed to be, getting reduced with this usage of Grow. So yeah, let's get started with a small demo of it. Let me just reshare my screen. Yes, that should be it. So what I have done is I have a kind cluster running in my local. See, so there's a kind cluster of 3 nodes running here in my local just for the demo purpose, right? And here is the resource graph definition that I have created. Completely everything from the doc itself for easy implementation. In case if you want to, you can just go to the official website and get this from there, right? What I want here is I want my custom application as my Kubernetes custom resource, which when created needs to create a deployment. So I'll just show the template that it's being used. So this is the actual scene. This is the actual YAML for any deployment that it needs to create, right? So you need not need to present API version kind, metadata, and all this stuff is completely abstracted out. So this is the actual YAML for getting a deployment, right? So everything is referred from here itself, right? If you see, it's the schema.spec.name. So it's schema.spec.name. So there's this template, how this templating works. In here, for the replicas, the same, right? Schema.spec.replicas and schema.spec.image name, right? That's how they work. You need not need to again provide the container name again. You need not need to create match labels, and all this stuff gets abstracted away completely. The very high probability of making mistake is somewhere it happens here. In case suppose you want to have a node affinity, maybe a toleration, all these steps can be directly presented over here, and developer is maybe completely abstracted away, and there is as such uh, complete elimination of making any errors in tolerations and node affinity. And then comes the service that needs to be created, right, as part of the application. So again, the same thing. People who have been using Kubernetes, it's very similar thing. These lines completely gets eliminated. In fact, this entire YAML is not even present. If you see this is what I showed in the presentation, right? Where do you see there is a there's any parameter for service? Of course, we can have ports as of now, just hardcoded right away. What you could do is you can have another field here that would mention ports, and then you can refer it from here itself. So that could be easily done. As you can already see, right, the selector here is completely here. It is referring to the selector match label. So in fact, you can refer the sub resource content in each other sub resource as well. So here it is what it's doing is deployment.spec.selector.match label. So here it comes to id deployment dot selectors dot match labels. So here it gets the key and the value that's again referred. So complete templating, very easy to read as compared to Helm, right? So if it's in what happens in Helm is it sometimes it goes beyond 1,000 lines. It's very hard to read, and even the indentation issues. Right? This is a one-time thing. You need not need to keep reading it again and again in order to understand. Once it is created, it's very easy on your part. Right. The third thing that we wanted was the ingress to be created. Right. So again, here is the feature flag where we can control if it's to be included or not in the first place, right? In case if it's included, all these things get abstracted. See the thing that I was mentioning. You see the level of indentation that it is required, right? That is somewhere it's very evident that a person makes a mistake. Once it is templated away, it completely eliminates the risk of having any sort of issues at all. So this is something that is completely provided by resource graph definition. Another additional thing that I wanted to present was this additional printer columns. So what are these printer columns? So when you do maybe see if you do a get SVC, the things that are printed over here is something controlled through additional printer columns. So suppose I'll just cite an example. Suppose you want to see the image name that is present for a given pod or a deployment. So you need not anyhow you to get the hyphen out YAML, or you need to describe it. What if you could just get it from just running this get deployment, the image name is printed, right? It's much more easier, right? So that is something again possible through this Grow, wherein you can define the there is any number of columns that you want to be printed here, and I'm determining the printing the replica that is supposed to be present, the number of the given replicas and the available replicas. Is there any issues with the replicas running, and also the image naming how you want to do present. Right? Completely up to me. Highly customizable. So that is something Crow gives the advantage to us to suit build it to our use case. So that's how this gets. We need to create a template out of. Right. So what I'll do is, so it's very easy to install Crow. I have installed it already. So it's running in the Crow system namespace. I'll just show you the pod. It's just one single pod running that is supposed to be the controller, because at the end of the day, it's just a Kubernetes controller that is abstracting away the complexities. Right. I'm not diving deep into the concept of controllers and operators, because again that would take a lot of time. Right. So what we'll do is we'll just, so as of now, so this is again a kind, right? So the name is resource graph definition. So if I do is get resource graph definitions. So as such, there is no resource graph definition. Let me check for CRD as well. See, there is absolutely just one CRD, that is the one that I already checked, resource graph definition. So what happens is, as soon as you create this resource graph definition, it in return creates a CRD. Right? For the people who are been working with CRD, you'll be easily able to understand what it does is. So if I create this resource graph definition, right? Earlier there was only one CRD, right? Now if I check the CRD, there's another one CRD. We didn't create a CRD, right? We created a resource graph definition. So it in return created an application that could run a CRD for us, right? So it's the possibilities of using Crow and sorting up our use case is way too big. It's just the starting, right? We can pretty much group any sort of resources and make it very convenient for us to basically use Kubernetes clusters, right? So yeah, so that's pretty much done. So we have created the template to the Kubernetes cluster. Right now, what we need to do is, this is the YAML. This is application. Okay. So as of now, I'll just make sure that I show you that there is absolutely nothing running. So everything is running in kube system namespace. There is nothing in default, right? It's the ingress running. That's it. Nothing else. What I'll do is, so here as per my template, I have created the YAML as I need. The name of the application is my web app. Email that I want to use is maybe Nginx latest, or maybe Alpine. That should be fine. Need to easily get pulled. Right? Ingress is enabled. Right? So that's all that I have given to this application. Let's see what happens. I already told you that there is no deployment. Yeah, this is service and there is no ingress. Right? There's absolutely no resources as of now. What I'll do is I'll just create the application. So I have created the application. So let's check if any of that is created. Right? It has created the deployment. It's yet to scale. Right? It's yet to scale. It's working. So once the deployment is up, right, a service is getting created. Now it's increased. So it's completely sequential. Just to mention, I forgot to mention that. So once eventually the resources will come up, right? Once the deployment is ready, I mean the deployment is created, then the service get created and the ingress will create. As you could see, I didn't create any of the resources manually. I just created my simple application, just very start of it. But if you can clearly see it, right, all the resources came up all on its own. The deployment got created, the service got created, and the ingress got created. Let's see the application itself. Okay, get applications now. See, the image is also visible right over here. The replicas, the available replicas. So that's how easy is basically to use Crow. You create a one-time template for the Crow and you just start using this. So again, as it's a very the simplest I could show you right away here. It can, as per the use case, can become much more convenient as per you can pretty much shoot it to completely for as per your use case, so that it reduces the complexity of storing huge YAMLs in your Git repository as part of GitOps, right? Also, maybe what you can do is, in case there is existing huge YAML footprints present in your application, what you could do is you can integrate the screw and with your customize, maybe not help, I still prefer customize, to even reduce the further footprints and much more usable as per your use case. That is something I've been doing. So I just my personal suggestion from my side that it's very helpful and easy to maintain the work. I mean, manifest, right? What else I wanted to show? Yeah, I think. Okay, so application was something that I created directly, and the controller was smart enough. I mean, of course, configured to basically create the CRD for this application. We were not creating CRD; we were creating resource graph definition. The controller in return created the CRD and gets this done, right? So yeah, let's come back to slides. Hmm, yeah, just once the last slide for side. Yeah. So the key takeaways were the YAML sprawl is a platform problem, not a developer problem, of course. Developer need not need to be aware at all of what needs to be, the expert developer not to be expert in Kubernetes, right? They just need their use case to be done without much of an hindrance. Crow enables server side Kubernetes native abstraction, as it clearly saw what it does, how it is abstracting away the difficulties that one needs to go through for eventually new to Kubernetes. Yes, yes, less YAML that we clearly saw, stronger guardrails because only limited parameters to be present and better GitOps workflow, as I already mentioned. And of course, a practical step towards scalable platform engineering. Yeah. So as we are adding productivity more to the platform engineering, right, by abstracting away the uh, key places where there is a very high chances of making mistakes, we are adding to platform engineering. So yeah, that's pretty much about the session. Thank you so much. I think I have some questions. Let me check. Yeah, Jagdish. So yeah, as I already see Sangram already mentioning about it. So that is something again, is a very complex thing in the very first place. Okay, so the person needs to first of all learn the Go programming language. Then he or she needs to understand Kubernetes internal working, the controllers, how the operators work, right? All these things are need to be learned in the first place. Then only he or she will be able to create an operator and all these things. So Crow is something that is leveraging up the abstraction right there, and you just need to create the template. Just the YAML is something that you need to be aware of as a part of a platform team, and yeah, this that pretty much would solve things. Cell, cell is something. I would say is a much more advanced concepts as in present. YAML would just is pretty much static, and cell is pretty much like suppose I'll just give an example again. How do I cite it? Common expression language is primarily used as a validations a lot of times. Personally, I have used it in Kiverno, so wherein we makes sort of filters wherein you define a given set of resources must be compliance with maybe a given label, right? Such a use case would suffice that. But YAML is completely static. Given it has a lot of use cases, but cell is something again is very dynamic and used in pretty much all the Kubernetes server side components, such as maybe a controller, right, or maybe a operator that you create, right. So that sort of level, the usage of common the CEL is. Yeah. Do we have anything? Yeah. Okay. That should be all, I guess. No, if you, in case if you have any questions, I'll be very happy to answer. If you can directly reach out to me on LinkedIn or maybe WhatsApp, that should be. I'll be very happy to answer your questions. Yeah, that should be precise as mentioned. Right. Okay. Thank you so much, everyone, for joining on this Sunday. It's really, I believe, very hard for people to join on Sundays. That too on a long weekend, in fact. Right. Thank you so much. As for the very first meetup of January, I do see there is a very great hope for long time success for our community. Right. We'll be definitely looking towards making this offline, as this was very done in a, I would say, yeah, uh, right. So we are still looking forward to making it happen in offline mode. We do see, in case if you feel like you want to collaborate and maybe uh, like may increase the reach of our community, please do reach out to us. We'll be more than happy to help you out. Right. So yeah, that's pretty much from our side. Instagrams, if you want to add anything to it. Okay, cool. No worries. Yeah, that's pretty much from our side. Thank you so much. Thank you everyone for joining us. It's been a great pleasure. In fact, it was very first time for me to host an event. Yeah. Hope pretty much it was a very insightful session for everyone. Good to see something, of course, we can only have it offline, but I'm looking forward to the same. Thank you so much. I'm just ending this session. You guys can definitely drop on. Thank you so much.